Hi students, hope everyone is fine and safe. It gives me immense pleasure to welcome you all to my new video, and today's video is about basics of communication part 2 in this lecture series short range wireless communication. We are just seeing basics of communication. In previous video I've explained what is modulation, what are the types of modulation, and in this video we're going to see what is meant by sampling, what is quantization, what is multiple access techniques, what is multiplexing. I believe this video is going to be a framework, a base for you to understand various concepts in short range wireless communication. Right? First, we'll start with sampling. As I said in previous video, we have just seen modulation techniques, types of modulation, right? And the purpose of modulation is long distance communication. And similarly, you ought to know very important aspect in communication, sampling, right? And I already said what is analog signal, right? We can represent a sine wave, a continuous signal, right? Using a sine wave. Sampling. What is sampling? Sampling is a process of converting a continuous signal into discrete samples, right? I reframe that again. It is the process of converting a continuous signal into discrete samples, right? That is, it is the very first step to convert a continuous signal to a digital signal. It is not the process which is going to convert a continuous signal into a digital signal. It is a process. It is the first step to convert a continuous signal to a digital signal, which means sampling, what it will do, it will convert this continuous signal into discrete samples. It will convert the signal into discrete samples. You can see here, if this is a continuous signal, we can take this, like we can chop this signal. If you're going to chop the signal, it will be like this, right? So if you're going to combine the signal, you will obtain the original signal back. The purpose of sampling, you have a lot of purpose for sampling. The very important thing is you can able to reconstruct the original signal very effectively using the sampling, right? And apart from that, it is the very first step in converting an analog signal into a digital signal, right? So whenever you digitize a signal, right, you form a digital version of the signal, right? It is very easy to process the signal. Whereas in analog signal, it is very difficult to process the signal. Whereas in digital, we can do uh, processing. It can be stored. It can be transmitted. You can able to do a lot of processing to reduce errors, to improve the efficiency. All those things is possible, right? So that is the purpose of sampling, right? So as of now, you have to understand sampling is process of converting a continuous signal into discrete samples. So now, if I take this as a signal, as I said, this is the continuous signal. And after sampling, I will be getting discrete samples like this. I'll get discrete samples like this. And still, this is not a digital signal. This is just a discrete samples, right? And what is quantization? Quantization is a very important step where it is the process of digitizing the samples. So what is it by digitizing the samples? Now, we already know this continuous signal is being converted to discrete samples by using sampling. And now by using quantization, I am going to digitize this sample. That is, I'm going to assign digital values. That is, I'm going to give 0, 0, 0, 1, 1, 0, 1, 1, something like that, right? So it is the process of digitizing the samples is called as quantization. And now you can see here, only after performing sampling and quantization, a continuous signal is changed into a digital signal, zeros and one, right? So the very important thing you have to understand is, in order to convert a continuous signal to a digital signal, you need both sampling and as well as quantization, right? And this digital values can be assigned like this. Say, for example, this is a quantizer. The quantizer will have its own digital value 0, 0, 0, 1, 1, 0, 1, 1, like this. If you want to send the samples to this quantizer, based upon the samples, the digital values will be assigned. Based upon the amplitude of the sample, the digital values will be assigned, right? And rounding off will be also taking place. That is called as quantization error. That is completely different, right? But as of now, understand that quantization is digitizing the samples, right? And whenever you come across this particular term, ADC, analog to digital conversion, analog to digital converter, there are devices which can convert analog to digital signal, right? By now you can able to understand, if you take any particular analog to digital converters, you will have sampler and quantizer in it, right? The very first step to convert a continuous signal to digital signal is sampling. It will convert that into discrete samples, and then it will be digitized using quantization so that we can able to convert it to a digital signal, right? So that is about sampling and quantization. You can see these are the samples where these samples are assigned with different digital values by using quantization, right? And you have a lot of rules and regulation to perform sampling. We have sampling theorem, which tells you how to perform sampling. But as if now you understand that sampling has to be very effective. If the sampling has to be very effective, then it has to follow this particular condition. That is, Fs is greater than or equal to 2Fm, right? That is, only if it satisfies this condition, the samples will not overlap, right? Say for example, if it is uh, uh, greater than Fs, then it will be called as oversampling, and this is perfect sampling where Fs is equal to 2Fm. But if it is Fs is lesser than 2Fm, then overlapping will take place, where we call this as aliasing, where a lot of distortions will take place. So in order to overcome the distortions, or in order to reduce the noise, the sampling has to be done very perfectly at Fs is equal to 2Fm, right? And these are the advantages and disadvantages of sampling, where, as I said, it is the very first step in converting a continuous signal into digital signal. And by taking at specific intervals, we can able to compress the original signal, which will result in a very efficient transmission. And it is very easy to process these signals, and we can able to use various algorithms. These are the advantages of sampling. And when it comes to disadvantage, the very important thing is, if the sampling rate is poor, it will cause aliasing, that is, it will result in distortions. And in the process of analog to digital conversion, definitely we need quantization, where during quantization, definitely rounding off will take place, some information will be lost, right? And while conversion analog to digital, many errors due to the factors of quantization, noise, temperature variations can happen, right? These are the disadvantages of sampling as well, right? And that is about sampling and quantization. See, the objective of mine for this particular video is, I want you people to understand what is sampling, what is quantization, so that whenever you come across this particular words, you can remember whatever I said, right? So the another important aspect in communication is multiple access technique. When it comes to multiple access technique is accessing the channel, that is various users accessing a single channel, that is called as multiple access technique. A very good example is the mobile, right? The mobile users, lot of mobile users access the same spectrum, the same range of frequencies, right? Single tower, the range of spectrum, it is accessed by different users. That is called as multiple access technique. A single channel is accessed by multiple users, right? And these multiple access technique is divided into three important uh, classification, which is FDMA, TDMA, and CDMA. Frequency division multiple access, time division multiple access, and code division multiple access. So you got to understand this multiple access technique. For this, I'll give you a very good example. Consider a particular channel. Consider a particular channel, right? Consider this channel bandwidth is 100 megahertz, right? Now, what is meant by FDMA? What is meant by TDMA? Now, the channel has 10 megahertz and we have 10 users, right? From the name itself, you can understand FDMA is frequency division multiple access. If there are 10 users and we have 100 megahertz, then this 100 megahertz is split into 10 frequency slots. That is why it is called as frequency division multiple access. The complete bandwidth is divided into different frequency slots. So it will be, this will be 10 megahertz, and this will be 10 megahertz, this will be 10 megahertz. And each and every user will be allocated with one particular channel. That is one particular 10 megahertz, right? This will be for user 1, this will be for user 2, this will be for user 3. This is called as frequency division multiple access. The entire bandwidth is divided by frequency slots, and each frequency slot is given to the user. Now, what is the advantage and what is the disadvantage of this particular FDMA, right? Each user, we have 100 megahertz, right? And each user right now can able to access only 10 megahertz because it has been divided into different frequency slots. So that is the greatest disadvantage in FDMA. Even though we have 10 megahertz channel, each user can able to enjoy only 10 megahertz. But the greatest advantage is there is no time limit. They can use any time. There is no limitation in time. But in frequency, they can able to use only 10 megahertz. That is the advantage and disadvantage of FDMA. Each and every technique has its own advantage and disadvantage so that it can be used in varieties of applications. When it comes to TDMA, time division multiple access, uh, the same example, you take 100 megahertz channel, 10 users, but right now, instead of frequency slots, in TDMA, it is divided into different time slots, right? So each and every user, that as you can see here, it will be divided into different time slots. Say for example, 1 hour slot. This is 1 hour, this is 1 hour, this is 1 hour, this is 1 hour. So each and every user right now will be allocated time slot. So which means each user can able to access the complete 100 megahertz. They can able to access the complete 100 megahertz without any problem. But the disadvantage here is they can able to access only for certain time. That is only for 1 hour in this example, right? And again, they have to wait for their turn. So that is the advantage and disadvantage of TDMA. And when it comes to CDMA, code division multiple access, there is no limit in time, no limit in frequency, right? This is where this is the very important technology where it created the greatest revolution in mobile communication. CDMA, code division multiple access. All the 10 users can able to access the complete 100 megahertz at any time, right? How is it possible? Each and every user will be allocated with a separate code, unique code, which will make all the communications very unique, right? So no overlapping will take place, right? So that is called as code division multiple access. So I believe you will understand what is sampling, what is quantization, what is multiple access techniques. And the last one is multiplexing. And you got to understand the difference between multiple access and multiplexing. Multiple access is allowing different users to use the same channel, right, at the same time. That is called as multiple access. But multiplexing is using the same channel by different users, but all this user signal will be combined and transmitted in a single channel. That is called as multiplexing. You can see here, multiplexing is combining all this different signal, right? It will be combined and it will be transferred as a single signal here. And at the receiver side, it will be demultiplexed and it will be sent to different users, right? So multiplexer it will be used in the transmitting side and demultiplexer will be used in the receiving side. And now you understand the difference between multiplexing and demultiplexing. And uh, the explanation for frequency division and time division remains the same even here for multiplexing, right? Whatever I said for multiple access, it is same for multiplexing. You can see here, this was frequency division multiplexing. Now you know what is multiplexing. Multiplexing is combining all this signal and transmitting in a single channel, right? And demultiplexing is then separating all these channels and giving to the same users. Now you can see here, this channel is divided into different frequency slots, right? And each frequency slot is assigned for different users. They use the same channel but in different frequency slots. That is, the frequency slots will be different. You can see the frequency slots is different but time is same. They can access at same time, right? And what is time division multiplexing? Here, there is no frequency slots. You will have time slots, right? So you can see you have different users here. First thing, you can see the first user will send one particular message, and then second user, then the third user, then the fourth user, and again the first user, which means each and every user will have its own time slots. Only in that time slot they can able to transmit, right? Everything is multiplexed and transmitted, but they can able to transmit only at that particular time, right? And here I can say here the time is different. The time is different, but frequency is same. All the users will be using the same frequency but different time slots. Here, all the users will use different frequency but at the same time. That is the very important difference you have to understand between frequency division and time division multiplexing, right? So today, what we have seen is we have seen what is sampling, what is quantization, what is multiple access techniques, what is multiplexing, right? I believe this video will be very basic video which will be very helpful for you to understand different terminologies in short range wireless communications. Thank you, my dear students.